Hi, everyone. Thank you for coming. Today we have Dr. Bill Hayes, a rattlesnake expert from Loma Linda University. He's going to talk about rattlesnakes and venomous snakes throughout the country and introduce you to some of his own rattlesnakes. I hope you have a wonderful time. Thank you for being here.
So I love seeing the kids here. It's great. We have a very young one. Two very young ones. Oh, my. Are you two twins?
Yes, they are.
I am too. How many of you like snakes? Okay. How many of you do not like snakes? I love it. I love it that people want to hear about rattlesnakes. That's the best part of my career. I actually study iguanas in the Bahamas and Galapagos Islands and birds in the Bahamas, but everybody wants to hear about snakes. Okay, so I'm going to give a PowerPoint presentation. It's going to last a good while, okay? And then we're going to discuss these topics, all right? That second item says basic biology. Can you read that? Yeah, wow. And coexistence and fun topics. We'll see some live snakes. I would normally have these in nice plastic clear containers, but I've got students with those at a San Bernardino event, okay? San Bernardino County Museum event. So I'm gonna pull them out and I'm gonna wrap them around your necks. Who wants a snake around their neck? Yeah, I know you do. Okay, so, and then I'll certainly answer questions, okay? So let's talk about venomous snakes in the US. We have copperheads, cottonmouths, and rattlesnakes. Copperheads and cottonmouths are back east. Rattlesnakes are throughout almost every state. And these are viperids. They're vipers. They have movable front fangs, right? And then we have coral snakes east of here. They almost make it to the California border. And sea snakes, about every 20 years, one or two will wash ashore here. But they're further south off the coast of Mexico, Central America. But they have short, rigid fangs in the front of the mouth, okay? And their venoms are generally much more toxic. So here's how to tell them apart. The rattlesnake, of course, you'll recognize this structure. What's that, kids? That's a rattle, yeah. And the non-venomous snakes have a beer can on the head, okay? But look at the tail. Look at that tail. Really fine and skinny. That's the key way. But if you know, you just always treat every snake as dangerous, kids, okay? Every snake is dangerous. What do you do when you see a snake? I have something, you take 2 steps back, Jack. Can you all say that? 2 steps back, Jack. All right, so we're very careful with snakes because these ones can put you in the hospital, okay? And very rarely, they could put you underground. Okay, so in terms of diversity, rattlesnakes are only in the New World. We have 48 or more species. Everybody has different ideas what a species is. We have a good 24 species in the US, and I'll take questions later, okay, at the end. We have the hotspot of diversity is Mexico and California. Depending on number of species, there's a question about that, but we may have as many as 9 species, okay? That's a lot. Here's the ones right in our general area. We only have 1 right here in Idyllwild, but if you go much further down the hill, you pick up 2 more. If you go down in the desert slope, you start picking up a couple more. I'll walk through these real quick. So here's the red diamond. Isn't that a pretty snake? Look at the black and white tail bands. You'll see that it lives in this kind of habitat, and there's this range. Here's the southern Pacific rattlesnake. These are up here in Idyllwild, okay? They're from the coast to the mountains, very widespread, and that's their range in green. And then we have color variation. Some are dark, some are pale. Then we have, oh, this baby has a yellow tail, and in the adult that becomes all black, all right? And then we have the speckled rattlesnake. You start picking that up at double view if you go south of here. As soon as you start getting out of the pines, you start picking this up. They love rocky areas. You'll see the rocky canyons they live in. This is their range in red. And they basically match their colors, not because they can't change their colors. To a tiny little extent, yes, but they're just born in the areas where they live to look like the rocks around them. Isn't that amazing? In fact, the rocks can even look like them. That's pretty extraordinary, right? Look at that. Amazing. Then we have sidewinders out in the desert. They don't get real big, okay? And how do they crawl? Sideways, you betcha. I should get a video of that in here. but they leave these J-shaped trails. That's their habitat and their range. There's a face only a mother can love. And the horns kind of protect the sand from injuring their eyes when they go in and out of these sandy burrows. Here's the western diamondback. You start picking this up closer toward Salton Sea. But this gets big and loves the desert, but it gets up into mountain areas as well. And there's its range. And this is the creature that gets rounded up in Texas and New Mexico and elsewhere, these horrible roundups. And these snakes are all butchered. They usually have their heads chopped off while they're alive. Now, for us, we would die pretty quick. But these animals are cold-blooded. The better term is ectothermic. Their temperature comes from outside. They don't generate their own body heat. And so because they have a very slow metabolism, they can remain alert and perceiving pain for 40 minutes or more. Don't chop heads off of these snakes, okay? And if you go further north above the San Bernardino Mountains, you're in the Mojave Desert, and you get this creature, the Mojave. They have black and white bands too, but mostly white, very little black. And their venom's more toxic. But the Southern Pacific rattlesnakes here in Idyllwild area is very similar to their venom. We have weird things going on with venom that my students and I have been studied. We've sampled venom from over 1,000 snakes. But these live in the creosote brush desert, really, okay? And here are some non-venomous snakes that are all pretty, almost as pretty as some of the people here. And so here's the gopher snake. Some people think that looks like a rattlesnake, but look at the tail. Gets skinny there. And they get fairly big. We have western coach whips. They make it this high. And this is a diurnal snake. You only see it at daytime, but they're very fast. Here's another very fast snake, the striped racer. And then we have the California king snake. Why would it be called king snake? It eats other snakes, okay? And it'll eat rattlesnakes, which some of you might think is a good thing. I don't like that personally. Here's rosy boa. I have a rosy boa for you to look at. I believe yeah. And they're up here in the mountains. And they're pretty. Look at the tiny little eyes, very gentle. Here's a glossy snake, mostly down lower in the desert. And here's a mountain king snake. We have these right here. Is that a pretty snake or what? Long-nosed snake, more so really just down in the desert. They're not up here. And least-nosed snake. Oh, I want to mention, some of these snakes have enlarged teeth in the rear of their mouth instead of the front. And they do have a gland there that secretes something, but it's such a small snake, it can't hurt us. We just pick them up. And I've never been bit by one of these, and I wouldn't be worried if I did. It's just, the venom is there, but it's for their, like, lizards and insects that they eat. Okay, here's another. This is really tiny. That's about the thickness of a pencil, size of a pencil. Here's a ringneck snake. They're up in these mountains. And here's the night snake. They make it up here in these mountains. So there's quite a variety. I'm not showing all of them that are mildly venomous. Again, we don't have to worry about them. You only have to worry about the rattlesnake, okay? And your fears. Let's talk about the biology of these snakes. So they're secretive animals, and the easiest way to learn about them is to attach these little radio transmitters, like on the back of this frog. And but we often implant them inside the body, and they send off a signal, and we have an antenna, and we can move the antenna to where it's pointed, where the signal is strongest. It makes a louder beep, and we can walk right up to that snake and find it whenever we want, which is pretty cool. Usually find it. And here's how we put it in the body. And anyway, so we can repeatedly go out and we can measure how much activity they have. So these are months. January to December. Do you understand that, how that works? Not really? Okay. And here's the activity, and you can see that the two species of rattlesnakes are most active in spring and again in fall. In the summer, it's just too hot. And in the winter, they're hibernating. They crawl down in holes in the ground and say, I've had it. It's too stinking cold. But they also will mate in the spring, and one of these two species will mate again in the fall, okay? And that's kind of typical of rattlesnakes. So here, males show higher levels of activity than the females. That's pretty much throughout all rattlesnakes. Here's their daily movement, and here's bites that have come to my university hospital, Loma Linda. You see a correspondence there. And a lot of these bites in the fall, That comes from babies. How many of you want to pick up a baby rattlesnake? You got to be real careful, okay? Now, what's interesting is the summer when it rains, we're kind of in the desert. And so the rain droplets will form on their skin and they will start drinking from their skin and they'll become more active as soon as the rain hits. And here's a place in Arizona where it's really conspicuous. And they all crawled out to coil up and get this rain on their bodies. Pretty cool, huh? Here's some interesting reproduction things. This is supposed to go somewhere else, sorry, but they tend to be annual breeders. I guess this is where I wanted it. I have some other slides that I've hidden. So the males breed every year, often spring and fall. And if they breed in the fall, they store the females store the sperm over the winter, and then in spring, they release the sperm in their bodies. It fertilizes the eggs, and they can get mated again by another male, okay? And, but the females often, they may copulate in the fall, they ovulate, and now they have eggs developing in their bodies, they give birth, but they've used up so much fat, they often have to wait a whole nother year to rebuild their fat before they can mate again, okay? It's rough on the females. It's tough to be a female, right? What do you know? Okay, so here's a little, males have 2 copulatory organs. Snakes and lizards, that's true of them, and sharks and rays have 2 copulatory organs. Kind of interesting, 2 related types and 2 related types. And they'll insert one of those into a female, and 20, 30 minutes, they're done with their deed. That's what they look like, okay? And kids can explain all that to your mom, dad. But sometimes the males are like, teenage boys, okay? They just get fighting with each other because they fight over girlfriends. Just ridiculous, right? You'd think they'd grow up, but they don't behave like this until they're old, and it's like they just didn't learn when they were young or something. This is the babies wait a minute. These are coming out of eggs. Rattlesnakes do not come out of eggs. What happens for them is they're kept inside the mother in a transparent membrane for the duration of the summer, and when she gives birth, that membrane breaks up pretty quick, okay? It breaks almost immediately. And out come these babies, not really in eggs. And what's interesting is the babies will stick with the mothers for about a week. Do you know how long a week is? Okay. And then the babies will shed their skin, and now they have a really tough skin because they were living in this wet environment inside their mommy's tummy. And now they have this really tough skin, and they go their own way, and the mom goes their own way. But for that week, the mom becomes more defensive. She's like, you don't mess with my child. Good mom, okay? So here's some really crazy facts. Long-term sperm storage, females can store the sperm, as I mentioned. The record is like 6 years. Parthenogenesis is rare, but once in a while, a female can give birth without having been mated, okay? And she only gives male offspring. It's a weird phenomenon. And politicians are more dangerous. We might as well throw that in. Okay, we have a thing called social buffering. What's social let's just talk about social behavior first. Snakes often overwinter in communal dens, especially high elevation. So there's a popular trail near here where you can put your hand on a rock to rest and you don't know it, but there's rattlesnakes in a crack a foot from your hand. Hold on, it's on timer, I think. Maternal attendance of young, the moms, again, often, they actually not just stay with the babies, but they often aggregate multiple females at the same spot. When they're all born, they'll follow each other's scent to where they spend the winter. They're capable of kin recognition. They know who's who. They can form social networks where it's like, I want to hang out with you. I don't want anything to do with you, okay? And so social buffering is the notion that when we're in a stressful environment like war or whatever, being yelled at by our spouse, whatever, we feel less stress if we are with a companion. And it could even be a dog. There's been a lot of research on this in social animals, mostly mammals and birds and even fishes, and a termite study. Nobody studied this in reptiles. So we thought maybe it would be something that exists in rattlesnakes. So I had a couple students put electrocardiograms. We were taking electrocardiograms. They put electrodes on these snakes so we can measure heart rate. What happens when we get stressed? Our heart rate goes up, okay? And so then we put them in a bucket and we would release a couple pins and the PVC pipe would go ding, ding, okay? And so we tested the snakes. We tested the snakes either alone with a rope, just as a control. Maybe it was another object rather than another snake, and then with a companion. And we measured their heart rates. And the heart rate would calm down after about 20 minutes in the bucket. And then when we dinged that thing, we would get an increase in heart rate, and then it would slowly drop again, okay? So we measured that, and as long as the heart rate slowed down quite a bit when they were in the bucket, if it stayed high over here, we couldn't tell a difference. But as long as the heart rate calmed down, we saw a real difference, okay? So there was no difference between the control and the rope. There was no difference between but there was a big difference between the companion and the other two treatments. So when they're with a companion, their heart rate goes up less. They experience less stress. And we had a lot of coverage of this research. It was so exciting. I don't like cheesy headlines. But these were nice because they make the snakes more relatable. They're not that different from us. They experience stress just like we do, and they feel comfort when they're with a companion, okay? That's pretty wild, huh? Personalities. Personalities. You guys, adults, you kind of know what personalities are, and these researchers measure these in humans. You kids, you know that there's nice kids and there's jerks, right? That's personality, basically, okay? And so we can ask, do animals have personalities? There's a lot of research showing that there are consistent differences. Some individuals are more exploratory. Some individuals are less so. Some are really defensive all the time. Some studies suggest we see this in rattlesnakes. We wanted to test this in how they use their venom. So count the number of pulses, 1, 2, 3, and 4. 4 pulses of venom came out there, okay? So that snake was a little ticked off, all right? So we're counting pulses, we're measuring the amount of venom. Here's the amount of venom by each of, I think we had close to 50 snakes. So in the first trial, second trial, and third trial, that snake basically gave the same amount of venom each time, not much. And then this snake gave a little bit, and then he gave a lot. So we're looking for consistency. The snakes that tend, and here's a measure. This is a measurement that's hard to explain, but it's basically measuring consistency. And sure enough, of these 4 behaviors that we're seeing, we have an effect big enough to say that there are consistencies. Some individuals are not giving a lot of venom. Somehow I have a timer on my slides. I'm kind of mad at that. I'm gonna have to go in there and fix that. Okay, but some animals are really out to get you, but that's not a good way to look at it. They're scared of us. They're just defending themselves. Let's talk about the rattle. When they're born, they just have this. They shed within about, well, let me describe it here. Here's the pre-rattle. They shed that within about a week to 10 days, and now they have this single button, and then every time they shed, they add another segment, okay? Now, they can shed 2-3 times a year when they're young. So you can't really count the number of rattles and say, 7 rattles, they're 7 years old. That's probably a 3 or 4-year-old snake, okay? But then once they get to be about 10 rattles, they start breaking off. So the rattles are simply modified scales that hook onto each other. You have to have this little shoulder here for the next one to hook over top of it. And this snake, on an island in the Gulf of California, Catalina Island rattlesnake, is not the Catalina Island in California here. I'll talk about that later. But on this particular island in Mexico, none of them have rattles. That little shoulder of the segment is defective. And we think that those who had the defect, they survived just as well because there's hardly any predators there. Okay, so they've all lost that. Now, these snakes provide important ecological roles in nature. They're part of the food web here. Different animals feed on each other, right? And they're in the, they're the top predators, tertiary, not the very top. So they're food for some animals, and they eat other animals, and we need them. We need them, okay? And nature that we have gives us remarkable ecological services. We get food from it, water, clothing, building materials. We can't live without that stuff. We get recreation, emotional support, oxygen production, soil formation. We need this stuff, and it's actually been valued at $125 trillion per year if we were to replace it. We can't lose this. We have to maintain these ecological services, and anytime you start pulling animals out of the ecosystem, you screw things up. You screw up the services, okay? Let's talk about the venom. We all like venom, right? So here's how they use their venom. This is a secret, but I'll let you in on it. They just ask you to drink it, that's all. Okay, so here's the apparatus. They have big triangular heads. I'll show that to you with some live animals. Again, I'm going to show you live animals. But here's the gland, a gland in each cheek. They've got a venom duct that squirts the venom out these fangs, and there's a sheath that covers the fangs, and when they bite, that sheath gets pushed up, okay? And the venom flows through the fangs. Oh, we got a replacement fang ready to pop in there. They use the venom for two major reasons, certainly to get food. It immobilizes, it kills the prey quickly. And then I'll tell you about this in a few minutes, but it helps them relocate their food, and in some cases, it can definitely accelerate digestion because it's digestive in quality in many snakes. And some of the food they eat, they're immune, okay? So a squirrel, a ground squirrel, who all knows what ground squirrels are? Yeah, okay? Now, once the baby's about 6 weeks old, it's tough for a rattlesnake to kill it. They do, they eat them, but it's tough. They develop tremendous resistance. So there's this kind of battle between these food items evolving to become more resistant. And when I say evolving, we're talking minor changes. And the rattlesnakes getting more effective venom to overcome that, okay? And then we have defense. And that protects them in two ways. Over time, a lot of these predators and antagonists, when I talk about antagonists, it's like deer will stomp them. The deer normally do not eat them, but they'll kill them, okay? So they've learned to recognize, oh, that's a dangerous snake. Stay away. But if they're dumb enough to interact with it and get bit, it hurts, okay? And it could save the snake. And some of the opossums can eat rattlesnakes indiscriminately. They're just basically immune to the venom. And researchers are interested in that. It's like, can we take their immunity and use it to save us from snake bites, okay? Research is important. How many of you adults recognize that? Wile E. Coyote? Okay, so let's talk about how they use their venom when they're biting. They have no ears. So they can't detect their food with their ears, but they have these amazing eyes that are very good at picking up their prey, and these facial pits. The facial pits actually see the body heat of their prey. I'll talk about that in a moment. So they typically find a place where they smell odors, okay? You know, here's a rat has been running through here, or a politician has been, and they set up, and when that creature comes along, they strike it, okay? And they inject the venom, and then they do the craziest thing, they let go. And now this animal runs off and they lost their food. Except that it's amazing. They become immobile for a minute or two because they don't want to attract the attention of this wounded animal that could come back and injure them. And then they start flicking their tongue. We call this chemosensory searching, and they literally follow the chemical trail left behind, okay? And when they find their food, they swallow it. And what's crazy is after they've bitten this mouse or rat, there's two trails, the incoming trail and the outgoing trail. How do they tell the difference? When they bite, the venom instantaneously changes the odor of that trail. They can tell the difference. That's pretty remarkable, okay? Of course, strike and venom injection is the most critical for success. Here, by the way, is that infrared vision. You can see that pit there. And this is basically what they can see of a mouse. And I had a colleague, he had a congenitally blind rattlesnake with no eyes, and it had no trouble striking accurately at mice because they have two forms of vision, okay? So how do they use their venom? this was part of my PhD work many years ago. We've continued this, but do they inject variable quantities of venom? All right, and we can assume that over time, individuals that make good decisions passed on the genes for those decisions, okay? And so over time, they've made good decisions about how to use or meter their venom, okay? So, and I'll just tell you that they do this. They make decisions about how much venom to inject. They're not dumb animals, okay? It's not always just a magic bullet. Sometimes it's less, sometimes it's more. So here are baby rattlesnakes. Here are adults. Who's injecting more venom there? These are into mice. These are predatory bites into mice, okay? And this is what we should expect, this exponential increase, because as they get bigger, they get more and more venom, all right? Their length increases in 1 dimension. Their venom gland increases in 3 dimensions, okay? And here's striking mice, okay? So the small rattlesnakes are injecting more venom into the big mice than the small. The large rattlesnakes are injecting more venom into big snakes than into small, okay? Here's cottonmouths from southeast. They're injecting more venom into larger prey here, okay? Here's mice versus sparrows. If you think about it, a snake bites a sparrow, and what happens if they let go of the sparrow? You guys, what happens to the sparrow? It could fly away. There's no trail. So they tend to hold on, and they tend to inject more venom, okay? Watch this. This is wild. I might have to, okay. So here's a little sidewinder here, coiled up, and here's a kangaroo rat, and this is very slow motion at night. It's tough to be a rattlesnake. That snake missed.
Oh my God.
Oh, what? It's got a second chance, and it's still missed. Here's another one. Watch this one. Is this fun or what? Oh, missed again. Now, they are successful about 50% of the time, but it's more fun to see the misses, right? More fun to see the misses, like as if you're married, right? This is a hilarious one. Watch this. Take that. So these are filmed by a colleague of mine in San Diego, Rulon Clark. Great stuff. But it's tough to be a rattlesnake, you know? That's rough. It's rough to be the food as well. Let's talk about human snake bite. Of course, you know, rattlesnakes are trained to where to bite us, but it's a rough experience getting bit by a rattlesnake, okay? How far can they strike? Maybe 1/3 to half their body length. The biggest rattlesnake you're gonna see in California is about 5 feet. It's very rare to see anything bigger than 5. I know we hear stories all the time about 10-footers. There's never, ever, ever, in more than 1 million rattlesnakes examined, probably never one has ever gotten close to 10 feet. But anyway, the babies can strike a full body length. Okay, they're just more agile. They can do that. But the adults are heavy-bodied. Again, kids, what do you do when you see a rattlesnake?
2 steps back, Jack.
2 steps back, Jack, right? Yes, don't shake your head. Have some influence on this kiddo. Okay, so here's a typical bite, but this is very slow motion, okay? Normally they're like Muhammad Ali. Some of you kids will know who he is, Muhammad Ali. So he's very fast punch, right? But this is very slow. Did you see how the tongue flopped from one side to the other? That's slow motion, okay? And here's, wait a minute. Oh, I'll get to another video. So we use these models right here to find out how much venom they would inject in defensive bites. We tried to get some, volunteers to line up, and we had second thoughts about that. So we decided to come up with these gloves. We put like water saline in, and we would make it warm like our legs, and we would rub it against us so it smelled like us, but man, it smelled like rubber still. Anyway, so here's a question. Are babies more dangerous than the adults? How many of you say yes? So a good number of hands are going up. The problem with that is that these adults have far, far more venom. I mean, these glands are bigger than the entire head of the babies. And it's a myth that the babies cannot control how much venom and therefore release all of it. That's the basis of the myth that babies are more dangerous. I'll talk about that in a moment, okay? So here are defensive bites. Who's giving more venom here? Here's the size of the snake, little snakes, big snakes. Here's the amount of venom they inject. The big snakes inject way more venom, okay? Where did this myth come from? I looked at old newspaper stories. I paid money to access historical archives. And before 1970, all the stories in California and elsewhere in the US got it right. The adults are the dangerous ones. More dangerous. The babies are dangerous, but the adults are more so. Then around 1970, everything changed in some crazy liberal place called California. They were getting it all wrong, and elsewhere was getting it right. And then after really the internet age social media age hit, it's wrong everywhere. And this is the most misunderstood myth. These are surveys of college students. N equals 7, that's not 7 students, that's 7 different classrooms, 10 different classrooms, hundreds and hundreds of students. And you can see that familiarity with this myth declines as you go east and north. So I think it originated in crazy California. So you guys got to tell everybody, the baby rattlesnakes are very dangerous, but the adults are much more so, okay? And I'll revisit this again. There were some physicians and a few others saying back in 2008 and 2009 that rattlesnake venom was rapidly evolving to become super toxic. And some of these doctors were reporting cases in which patients, for example, would have difficulty breathing. Okay, and it was just nonsense. I could go through some of the reasons why, but it's nonsense. The venom cannot evolve that fast. The comparisons were ridiculous because we had a new venom. Anti-venom came out in 2000. Nobody had data to support that. I think the bigger problem is we have super stupid humans. Okay, it says, man nearly dies after putting pet rattlesnake down throat. Would you do that? Okay, and I want to remind you, in about 5 or 10 minutes, I'm going to show snakes, okay? Here's another crazy, super stupid. Would any of you kids do this? No, we don't do this, okay? Sometimes you get a dry bite. This guy really got lucky there. Okay, and we've quantified that. It's maybe at most 10%. We wondered whether wearing long clothes would provide protection. Okay, how many of you think that makes some sense? So we actually tested these gloves with blue jeans, and we found whether it was a small snake or large snake, we had about a 2/3 reduction in the amount of venom that went into these artificial limbs during a bite. That's pretty cool, huh? Okay, island tameness. I've mentioned this. Santa Catalina Island. How many of you have been to Santa Catalina off of Los Angeles? Fabulous place. I just love it there. And my students were saying, hey, you know, these snakes, they should be tame, but they're actually more defensive, they thought. And I'm like, that sounds wrong. Maybe Kofefi. We better test this because that shouldn't be. And so we ran this behavioral trial where I'm capturing them. I don't know which snake I'm trying to pin and capture. We get venom from it. And we measured these behaviors, and basically rattling, no differences between the mainland and Catalina Island snakes, but these attempts to bite, how long it took me to capture them, and the amount of venom injected were all more for these Catalina snakes. And they should be tamer. Island animals don't have many predators. They're normally very tame. Here's the amount of venom, the snake length, the amount of venom, and here's the mainland snakes. And for any given size, these island snakes are giving you about twice as much venom. Why? We wondered that. We looked at bird data, and there were fewer bird predators out there, but this is interesting. Here's the mammal data. They have one predator naturally, the fox. And these are densities, but the big issue here is massive densities at one time for goats and sheep especially. Massive densities. And those have been now removed from the island because they destroy all the vegetation, just a mess. But in having all these animals running around, scaring these rattlesnakes, we've made them more dangerous to us. Our carelessness by introducing animals that don't belong there made them more dangerous to us. Here's some venom extractions. You want to see this? This is very slow motion, but this gives you another idea. I showed you one earlier of how the venom comes out. And you can be glad this isn't your hand that he's biting, but look how much venom that is.
Wow.
And again, independent control of the two fangs, right? Okay, so we have some interest in what's in the venom. And it's usually yellowish, about 80% water, but we got a lot of proteins, different proteins. You could have 100 different proteins present in a single snake's venom. We use fancy equipment to sort it out. The venom comes off this column. Here are the different venom components, okay? So this peak, for example, the red ones, that's Mojave toxin, okay? That's really bad, and they're in the Southern Pacific rattlesnakes right here in Idyllwild. But a lot of different venom components. And here's the annual frequency of bites. In the US, we have probably 5,000 to 8,000 bites every year, and only about 5 people die. So your odds of survival are about 999 out of 1,000. You might wish you were dead, but it's miserable. And you could lose a finger. You could lose movement of a joint. You could have your kidneys permanently injured. You could die. Bad things can happen, okay? But in terms of death, we have excellent treatment to reduce that. Without the antivenom, you might have 2% of people dying and a lot more severe injury, maiming, terrible injury. But the antivenom we have is fabulous, okay? What kind of animal, by the way, causes the most human deaths in the US? Any quick guesses? I heard cows. People, oh, we're gonna exclude people because that would be at the top. It's gonna be deer. People hit deer with their cars. And here's venomous snakes. There's just a number, 7, okay? So we have dogs kill more people, all right? So here's venomous animals, hornets, wasps, bees. Just for some perspective. By the way, what's the most dangerous in the world? Mosquitoes.
Oh, yeah.
And snakes would be, I think, number 2 there. I've hidden those slides, but anyway, we've done some research here at Loma Linda on snakebite severity. We quantify 6 different clinical symptoms with a score of 0, meaning nothing there, to 3 or 4, meaning it got really bad. And we can show that snakebite severity here. This is more severe, less severe. 2 factors are important to explain severity. Size of the patient. You can see that the bigger patients have less severe bites. And size of the snake. You can see in blue, these are the big snakes. Green, these are the medium snakes. And in red, those are the little snakes. Who's causing more severe bites, big or little? How about distribution of the bites? Whether you're bitten in the upper limb up here or the lower limb depends on males. Get bit more often. Snake size is not important. Patient age is not important. And whether illegitimate means you're messing with it when you should not. Legitimate means you didn't see it. It was not your fault, okay? And so if you're messing with the snake, you're more likely to be bit on the upper limb. And then we have distal versus proximal. That's further out from the wrist or closer, or the ankle, okay? And what's important here is snake size. The little snakes are more likely to get you further out, and the big snakes are more likely to get you further up, right? And if you're grabbing it, it's more likely to get you further up, okay? Don't grab it, kids. Whether or not you're messing with the snake, what's important here? I think you already have that figured out, some of you. Patient sex, yeah, males. And if you're using alcohol. So at Loma Linda University Medical Center, 80% of the bites are to males because we're stupid. 45% of the time we're interacting with the snake, which is stupid. 20% of the time, somebody's drunk or on drugs when they're interacting with the snake, which is stupid, okay? So snake bites are associated with the 2 most dangerous chemicals in the world, alcohol and testosterone. You want to explain that to your parents? Okay. Okay, so how to avoid this? Always watch where you put your hands and feet. If you're going out to your mailbox at night, maybe take a flashlight with you, okay? Kids, if you're playing ball with your dog and your ball rolls under a bush, look carefully before you reach under that bush. There could be a rattlesnake there. Be aware of your surroundings at all times, okay? Don't Don't get close to the rattlesnake. Back away if you see or hear one. Look at the property. Here's a nice clean property. There's no places for snakes to hide, but look at this. And it's not only good for snakes to hide, but so will their food. So they want to be there for the mice and the lizards that are hiding there, right? Here's a study in Loma Linda where we radio track these rattlesnakes. And you can see all these, this is 30 rattlesnakes with multiple observations. But here's where they're close to homes. And here's where we take them back out to the natural place. And here's this buffer that's plowed. That's plowed earth. And the snakes cross it, but they don't hang out there. We never saw one just hanging out there, okay? You can buy these stupid chemicals, but they're not gonna work. These chemicals, we don't have any good chemicals to repel snakes. Nets, that's tends to get wildlife tangled up in it and killed. You can buy screens. I could tell you people who install these. This is a good one here. That one, obviously, that's useless. But look at the gaps here. I mean, that's a fail. But you can get good ones, and I could tell you who to call. We get nuisance rattlesnakes at people's homes. A lot of people kill them, but there are people you can call to remove them. And if you remove them a short distance, they may return, so that's not the ideal. If you take them a longer distance, they're less likely to return. But they may now be more likely to die out there. They crawl a lot more, they're lost. But we did research on these red diamond rattlesnakes in Loma Linda and found no difference. So we recommend moving them about a mile away, okay? We have, for our pets, a vaccine. The problem with, how many of you have used the vaccine on your dogs? It's actually Western Diamondback rattlesnake venom. Now, this venom has a lot of metalloproteases, so you're gonna produce antibodies. The dog's gonna produce antibodies that protect it from this. Here's a Southern Pacific rattlesnake. They have these other components in their venom, myotoxins, and these are a handful of different things. So you're not gonna get good protection from Southern Pacifics. Your red diamond is very similar, so you're probably gonna get some protection. It's just limited efficacy. Rattlesnake avoidance training is best. How many of you have trained your dogs? So I see a couple hands. That's a good idea, and we have some data to support that. I'm not gonna show you. But they're using a collar. They put a little shock collar on the neck and give a shock, and some people say it's cruel, but it saves lives. There are dogs that would have gotten bitten that were conditioned. You know, it's like, whoa, that's gonna hurt me, okay? And so I encourage that. There's I can return to that if you want, but these are personal friends who are in Joshua Tree area. They do a nice job. Snake bite treatment, all these old methods suck. Anti-venom's the only good one. The sooner you get to the hospital, the better. This extractor device just sucks. Here's injury it actually caused. In our study, we did a research study, and it didn't reduce the symptoms of envenomation. And I'm gonna close in about 1 minute here with this last little bit, which is fascinating. We have venoms. Venoms are designed to kill. But we humans are clever enough to take those molecules designed to kill and convert them into something that can heal. It's remarkable. So here's anti-venom. We have to get the venom from the animal, inject it into a horse or sheep. They produce antibodies. We purify those antibodies, and we give them to you if you're bitten. It all involves research. It all involves use of animals. It does not harm the horses or the sheep, and it saves human lives all the time. Research on animals does save human lives. I've mentioned the dog vaccine. We have Byetta. This is from the venom of a Gila monster, and it's used to treat diabetes. And if you've heard of the GLP drugs, like what's the main one? Ozempic?
Something like that.
That's all derived from this, okay? From the venom of the Gila monster lizard. In fact, what's interesting is the package insert for Byetta says it comes from lizard saliva. They're not gonna tell you it's venom, okay? But it's magic. Integralin for heart issues from a rattlesnake. Here's something we did at Loma Linda. So when we have surgery on the brain, well, let's say surgery on the hand or arm, it's okay if you swell because it can get big, right? But your brain is locked inside this hard, bony case. And so if you have any bleeding and swelling, pretty soon you can die from it, very quickly, actually. And so what we did, this wasn't my idea, others, they did a little bit in my lab, but so they injected small amounts of venom 3 days in a row into rats. It provoked bleeding and swelling, and the rats would build up resistance to that. So when they did the surgery on the 4th day, they had less bleeding and swelling. Really fabulous, okay? All right, so rattlesnakes, they're important components of our ecosystems. They exhibit remarkable adaptations like ability to make decisions. They pose serious risks to us. We gotta treat them with respect. And research and education are just very important. It's very important for our understanding of the natural world and these misunderstood creatures. Thank you.